In C, it says the line L is parallel to BC and passes through A. Okay, so I've drawn a line here now that passes through A. Okay, and it says it's parallel to BC. So remember from earlier, BC, okay, was this line here, wasn't it? Okay, and it was actually perpendicular to AB. So the same will be the case here with line L. Okay, if line L is parallel to BC, that will also be perpendicular, won't it, to AB. Okay, and quite simply then we can determine the gradient, can't we, of L. Okay, so the gradient of L then will be the same as the gradient of BC, okay, which is -2. Okay, so we've got the gradient there. We've also got a point that it goes through. So that line L goes through A, doesn't it? So the point is -2, -3. Once you've got the gradient and a point, we can then get the equation of L. Okay, so the equation of L, quite simply, well, is using y minus y1 equals mx minus x1. So my y1 is there, -3. Okay, my gradient is -2, and my x1 is -2 there. Okay, so we've got lots of double negatives here, so make a plus, of course, and the same then in that bracket there, so it becomes +2. If we then multiply out that bracket, we get that, and then get everything to the left hand side. So I've got 2x plus y plus 7 equals 0. So that is my equation of line L there. Okay, so we can write it like that, or you can write it as y equals if you want to. You could have said y equals to -2x minus 7. Either sort of version there is fine. So then in D, okay, if we look to D, then it says the line L intersects the y-axis at D. Calculate the length of CD. Now, I know what C is, don't I? I know C, quite simply, is that coordinate there, isn't it? So it's K3, and remember, K was 5, wasn't it? So C is 5,3. It's just I don't know what D is equal to. Okay. All I know is that the line L intersects the y-axis at D. So if I look at my line here, okay, L intersects the y-axis at the point D here, okay. Now if you think about it, right, okay, I mean we could see from our accurate scale there what coordinate it might be, but we've got to actually show the workings, right. On the y-axis, okay, think about what's true, okay, on the y-axis, of course, x is 0, isn't it? If you think about it, on the y-axis, where that line crosses the y-axis, the value of x is 0. So we can say x is 0. So if we look at our equation then, that means y is equal to -7. Okay, I think that's pretty good there with the scale drawing. I've got my scale drawing spot on there because I think that's -7 there. Okay, but we've got to prove it, we've got to show that there. So that means then D will be 0 minus 7. Okay, so we also then know, of course, C is 5,3. So then to get the distance CD, so the distance CD, I use the formula then, the distance formula, x2 minus x1 all squared plus y2 minus y1 all squared. So you've got 5 take away 0 all squared, plus then 3 take away then -7 all squared. Okay, so if we work that out, that's going to be we will use a calculator on it, but that's going to be 125, and so then that simplifies then to be 5 root 5 when you square root it, and we're done.